Okay, let's find this limit. X is approaching 0. Okay, there's two problems. The first problem is if you plug in 0 at the bottom, it becomes dividing by 0, which is not good. Okay, we don't want to do that, right? So far, our goal was to get rid of that 0 somehow. And it looks like it will, because we also have x on the top. But it's not just an x, it's an absolute value of x. Now the thing about absolute value of x is that it behaves differently depending on whether you plug in a positive value or a negative value. But x is approaching 0. What's a little bit to the right and a little bit to the left of 0? One's positive and one's negative, right? So when x is greater than or equal to 0, what does the absolute value do if you plug in something positive in there? It does nothing. It just leaves it alone, right? What does it do if you insert a negative value in there? It returns a positive, right? But how does it do that? Think about it like this. How does it turn this into this? It multiplies the input by a -1. So you write it like that. Right? If it's negative, if that's negative right there, if that alone is negative, you negative it, so it becomes positive. Okay? Alright. That's very important. Left-hand limit. Okay. For left-hand limit, because we're talking about something that's a little bit less than 0. You can even do this if you want. Look, let's do it like this. X is approaching 0 actually means 0 minus delta, right? And this x at the bottom is just also 0 minus delta, right? So we get minus delta over minus delta, but this is absolute value. But what's the absolute value going to do to this minus delta? Delta. What is that equal to? -1. Okay, let's do the right hand limit. Okay, this time it's 0 plus delta. 0 plus delta, and this time it's just going to be delta over delta. It's equal to +1. They're not the same. Okay, how do you answer this question? So we know visually this is what's happening. Okay, as it approaches from the right, it's approaching 1. So the graph looks like this. One. From the left, it's -1. So this is the graph right here. Or this is a hole though. There's a hole here. Do you see how from the left and the right it's different? If it's different, we say the limit does not exist. You cannot say for certain it's a single value. So we say at that case, limit does not exist.